First we'll write as given secant theta plus tan theta is equal to P. We have to show that sin theta is equal to P square minus 1 by P square plus 1. So I'll use the identity, second identity, as secant square theta minus tan square theta is equal to 1. I'll write this as in the form of a square minus b square. So I'll write this as a plus b into a minus b. Then secant theta plus tan theta into secant theta minus tan theta is equal to 1. I'm writing this a square minus b square, then a plus b into a minus b. Secant theta plus tan theta is nothing but p. In the place of secant theta plus tan theta, I'll write as p. Then secant theta minus tan theta is equal to 1. Then secant theta minus tan theta is equal to 1 by p. So I'll assume this as the first equation. This one as the first equation. And this one as a second equation. So solving 1 and 2. Solving 1 and 2. What is the first equation? First equation is secant theta plus tan theta equal to P. Secant theta plus tan theta equal to P. Second equation is secant theta minus tan theta is equal to 1 by P. So I can cancel plus tan theta and minus tan theta. Secant theta, 2 secant theta is equal to P plus 1 by P. 2 secant theta can be written in the form of cos theta. Again, here there is no denominator, so P LCM. So P means P square by P plus 1 by P. So 2 by cos theta is equal to P square plus 1 by P. Both the denominators are same. Now what I am doing is I am reversing both LHS and RHS. Then it becomes cos theta by 2 is equal to P by P square plus 1. Then I'll cross multiply 2. Then cos theta is equal to 2P by P square plus 1. So I got the value of a cos. I use identity. First identity, sin square theta plus cos square theta equal to 1. If I move cos outside, then what happens? Sin square theta is equal to 1 minus cos square theta, right? So sin square theta is equal to 1 minus, what is cos theta value? 2p by p square plus 1, okay, whole square. I'm substituting the value of cos theta. Cos theta is 2p by p square plus 1. Then sin square theta is equal to 1 minus 2p whole square is 4p square by p square plus 1 whole square. So I am squaring both numerator and also to the denominator. Then sin square theta is equal to, here is denominator is 1. Obviously the LCM will be the same. So I'll multiply 1 by 1 into p square plus 1 whole square into p square plus 1 whole square minus 4p square by p square plus 1 whole square. So sin square theta is equal to p square plus 1 whole square by p square plus 1 whole square minus 4p square by p square plus 1 whole square. So I made the denominators same. Now I will expand this a plus b whole square in the terms of a plus b whole square. So sine square theta is equal to p power of 4 plus 2p square plus 1 a square plus 2ab plus b square by p square plus 1 whole square minus 4p square by p square plus 1 whole square. So sine square theta is equal to denominators are same p square plus 1 whole square. Then I write the remaining part p power of 4 plus 2p square plus 1 minus 4p square. Then sine square theta is equal to p power of 4 minus 4p square plus 2p square means minus 2p square plus 1 by p square plus 1 whole square. I can write the numerator as a square minus 2ab plus b square. So p square minus 1 whole square by p square plus 1 whole square. Okay. Even if you want, can check p square minus 1 whole square means this is in the form of a minus b whole square, p square whole square minus 2 into p square into 1 plus 1 square. So p power of 4 minus 2p square then plus 1. Are you getting the same? P power of 4 minus 2p square plus 1. Even if you expand p square minus 1 whole square, you will get the same. So sine square theta, I'll take both numerator and denominator square common, p square minus 1 by p square plus 1 whole square. So I can cancel square and square. So sine theta is equal to p square minus 1 by p square plus 1. So LHS equal to RHS. Therefore, LHS equal to RHS root.